All right, so now we're going to start actually graphing some of these trig functions. To start with, we're going to kind of ease our way into this. So we're going to start by looking at these without any shifts, and we're going to look specifically at just sine and cosine graphs, okay? So first of all, let's talk about this equation right here. So this is a generic equation for either a sine or a cosine graph. This one in particular is sine, but all of the rules are the same for cosine. It's just a different shape of graph. So that's going to be a thing that we look at. Now, if you remember when you were in Algebra 2, you did transformations of different kinds of graphs. So like say a parabola, right? In a parabola, you would have that y equals and it'd be something, and then x plus or minus something squared, and then plus or minus something, right? And all these different things did different things to your graph. So like this guy right here was like a vertical shrink or a stretch or a flip, and this thing moves you to the left or the right, and this thing moved you up or down, right? Well, if you remember doing that, it's okay if you don't, but if you do remember doing that, you can kind of see how there's a lot of matchup between these two things. So this A value corresponds to the A value that you had in your parabola, and it's going to do basically the same things. That's going to be your amplitude, and it's going to tell you about how tall your sine or cosine wave goes. When we look at this guy right here, this is your left or right shift. Similar thing here. The only difference is that we're dealing with B and we might not have dealt with that before. Okay, so that might be a little bit different, but it's the same concept. And then this is a vertical shift, just like how this was a vertical shift. Okay, so if you remember doing this from Algebra 2, then this is really the same thing. Okay, if you don't remember it, then you're going to learn it now. All right, so let's talk about what the different things in this equation do. So first of all, this guy right here is going to tell you your amplitude. Okay, now in a parabola, you care whether it's a negative or a positive number because that tells you which way your parabola is going to open. That doesn't so much matter with cosine and sine graphs. So when we look at this, we say that our amplitude is just going to be the absolute value of whatever A is. So you ignore any negatives, it's just positive or negative. So this number here, remember, amplitude tells you how far up and down your wave bounces. So this is going to tell you how far up and down your graph is going from the midline. All right, so the next thing that we're going to need is we're going to need to figure out what our period is. But actually, you know what? Before we do that, let's switch a little bit. Let's talk about the shapes of the graph, and then we'll start seeing how we're going to apply some of these things before we talk about all of them. So let's take a look at this guy, and we'll just look at graphing a sine wave and a cosine wave and what those look like. Okay, so they look very, very similar. They both look like the same wave with a couple of little differences. Notice we're in degrees here. Okay, so sine waves, your sine wave point is going to start at 0, 0. Okay, and then here's how I remember how to do these because there's a lot of points and you got to kind of remember it. So here's how I remember. The first point's at 0, 0. The last point is going to be at 360 or at whatever the end of your period is, but we'll talk about that more later. Okay, so you find these 2 points. Halfway in between on a sine graph, so that's 180 degrees, halfway between, you're going to be back on your midline. Okay, and then halfway between these 2 points, you're going to be at the peak of your graph, which is up at 1. So halfway between 0 and 180 is 90, so that's this guy right here. So halfway between, I'm up at the top. And then halfway between these 2 points, which is going to be here, I'm down at the bottom at -1. Okay, and once you have those 4 staple points, now I can kind of see, oh, look, there's a pattern, right? So every third line, I move to the next position. So from here on the third line, I know I'm going to be up here. Okay, and that's what the shape of my graph is going to look like. Kind of missed that one point, but you know what I'm shooting for here. Oof, it's kind of hard to freehand sometimes. Okay, so that's what your sine graph is going to look like. And the one thing that you got to remember here, sorry, there's a very dramatic moment for a sneeze to come in. All right, so the one thing you got to remember with sine starts at the center. Okay, you might want to write that down. Sine starts at the center. You get all those sort of sounds. All right, ignore the fact that center starts with a C. It's all about what it sounds like. Sine starts at center. Okay, now when we look at our cosine graph, the cosine graph looks a lot alike, but it's a little bit different. Cosine doesn't start at the center. Sine starts at the center. Cosine starts up at 1. Okay, and then at the end of our period, which is 360 for this guy, you're going to be back up here at 1. Okay, so far it's the same, but here's where the different part is. In a sine graph, the middle point is in line with the two edge points. On a cosine graph, your middle point is down at the bottom of your wave. Okay, so it's halfway between these two, but down at the bottom. And then halfway between these 2 points is where you're going to cross your midline. Halfway between these 2 points is where you're going to cross your midline. Okay, and that's what our wave is going to look like. And then again, once you know that pattern, right, every third block, I can see it's changing positions, right? So from here, 1, 2, 3 blocks, it's here. 1, 2, 3 blocks is down here. 1, 2, 3, it moved. 1, 2, 3, it moved. So 1, 2, 3, I'm going to be back down here. Okay, and that's what my cosine wave is going to look like. Okay, so as you can see, these things look a lot alike, right? If you took this graph and you shifted it over a little bit, you'd get that one. Okay, so they look very, very similar, which is why they have a lot of the same properties. So the trick is to remember, again, sine starts at the center, and then you just got to kind of remember that with sine, your midpoint's in the same position as your two endpoints, but with cosine, it's on the opposite end of your squiggle, okay? All right, so having established that, let's take a look at graphing some of these. All right, so we're going to start. I'm just worrying about amplitude right now, and then we're going to come back and talk about the other things. So the first thing that I'm going to do whenever I graph one of these is I'm going to say, okay, one, am I doing a sine or a cosine? Actually, you know what? I don't even need a sine or cosine graph yet. That's not the first thing I'm going to think about. The first thing I'm going to think about is the amplitude. Okay, so this guy right here, that's my amplitude. So my amplitude is 1/2. Okay, now we are not dealing with any shifts yet. Okay, this is a no shift day. So when we have shifts, we're going to have to think about this a little bit more. But for now, all that this tells us is since we're not shifting our midline, it's staying at the x-axis. My wave is going to bounce between positive 1/2 and negative 1/2. So 1/2 in each direction of the midline. So what I'm going to do is I'm going to start by just drawing in little dashed lines at 1/2 and negative 1/2. So I can see where my wave's bouncing between. Okay, so that's just showing me what are my boundary lines? What am I bouncing between? Okay, so that's the first thing that I'm going to worry about. Okay, now back up to this guy. What's the next thing that we care about? Well, the next thing that we have to care about is our period of our graph. So the graph's period. Okay, sorry, I'm trying to choose a different color marker. It's very strenuous. Okay, so the period of our graph, and we talked about period being how long it takes to complete a full wave. So like this is a complete cycle and it took 360 degrees, so our period's 360. All right, so when we're looking for the period of our graph from this equation, okay, it's all about this b value right here. Okay, so this guy right here is going to be the key. So what you're going to do is you're going to do, if you're in degrees, 360 divided by the absolute value of whatever b is. Okay, or if you're in radians, which sometimes you will be, you'll do 2 pi divided by the absolute value of b. So it doesn't matter if b is positive or negative, you just care about what the number part is. All right, so that's the next piece that we're going to look at. So let's look at this guy again. All right, so I need to figure out what my b value is. Here's my angle symbol, right? So we know there's a little invisible 1 in front there. Okay, so what that tells me, like this right here, that's the same as writing 1/2 theta. Okay, so that's telling me that my b value is 1/2. So my period, right, is going to be, well, am I in degrees or am I in radians? Look at all those pi's. We're clearly in radians. So I need to do 2 pi divided by this b value, 1/2. All right, now if you are good with fractions, that should be easy. If you're not good with fractions, the way that you divide fractions, keep the first one the same, change it to multiplication, and flip the second one. And you can stick a 1 under there if you need to, so that equals 4 pi. So my period for this guy is 4 pi. You're going to need to be able to calculate that. Okay, great. So now this is all the information I need. This is a sine graph, so I know sine starts at the center. So this starts at my origin, And then this tells me that 4 pi is going to be the end of my wave. So like how up here, I started here and I put my last point at 360. Well, this one is telling me that I start here and my last point goes at 4 pi. So there's the end of my wave. Okay, and then remember with sine, you find halfway between, and that's going to be on your midline as well. So here's halfway between, that's at 2 pi, so that goes on my midline. Halfway between these 2 points, I'm going to be up at the top. So I'm putting that right on my little dashed line there. And then these guys, halfway between, I'll be at the bottom. So I'll be at the bottom of my little dashed line. All right, great. So then that gives me all the information I need. I can kind of look at this and say, okay, every 2 vertical gray lines that you can't really see is when I shift position. So this brought me up and back down to the bottom, to the middle. So the next one's going to be up, and it's going to be after 2 lines. And then after another 2 lines, I'll come back down to my midline. And then channel your inner 5-year-old and play connect the dots. And there we go. That's what my graph looks like. All right, great. So let's try this next one. Okay, so this guy right here, we're going to do the same thing. So I'm going to start by looking at my amplitude. That's this guy. So the amplitude is 3. So the first thing I'm going to do is I'm going to put on my little dashed lines at +3 and -3. So I'm going 3 up from my midline and then 3 down from my midline. Okay, be careful because see how these guys are all fractions? They kind of cover up the first line a little bit. So just be careful when you're counting. I have a lot of people who will like accidentally skip this one, right? It should be 1, 2, 3. And I'll have a lot of people who go 1, 2, 3 and end up down too low. Okay, so just be careful as you do that. All right, so we got our amplitude. So now we need our period. So our period is going to involve this guy right here. So my period, I'm in radians. So I know I'm going to need 2 pi. So it's going to be 2 pi divided by this guy right here, which is 2. Okay, and 2 pi divided by 2 is just 1 pi. Okay, so now we just graph this equation. So this is a cosine graph. Okay, cosine is like a coaster. You start at the top and go down, right? So I'm starting at the top. Okay, my last point is going to be at pi, and it's also going to be at the top. So that's this guy. Okay, and then on cosine graphs, halfway between is when you're at the bottom. Okay, so halfway between is the bottom. That's different than sine. And then halfway between these two is where we cross over here. Halfway between those two is where we cross over here. Okay, and then that's enough for you to establish a pattern. As I'm looking at this, every 1 vertical line, I move to my next position. So after 1 line, I'm going to be back down here. After 1 line, I'll be back down here. 1 line, come back up. 1 over, come back up. 1 over, go back to my midline. Okay, and then over here, I can even do this side too, right? I have a little room there that I can use to fill my points. You need to make sure that when you're graphing these, that you're filling the entire coordinate plane. Okay, if you just give me that much when you're graphing this on a quiz or test, you will not get full credit for that. Okay, so make sure you fill the whole coordinate plane. All right, now these next 2 are the same thing. These ones are measured in degrees instead of radians. No big deal. Okay, we're going to do the same thing. So I'm starting by looking at this number. Okay, that tells me that my amplitude is 2. So I'm going to go in and draw dashed lines, 2 above and 2 below my midline. My midline's on the x-axis, so there's 2 above and there's 2 below. Okay, now this one's measured in degrees. I'm going to use this number right here for my period, but I'm going to do 360 divided by 4, whereas before we used 2 pi because we were in radians. Okay, now we're using 360 because we're measuring in degrees. And the way you tell the difference is that 1, the directions say degrees or radians. 2, when you look at the axis, you can tell. All right, so 360 divided by 4, that's 90. So my period is 90. All right, it's a sine graph. Sine starts at the center. So that starts right there. And then at 90 degrees, which is here, I'm going to be back on my midline. All right. And then in a sine graph, halfway between is where you cross back over. So halfway between is actually going to be kind of between two blocks. That is totally okay. That's going to happen sometimes, and it's not a big deal. Okay, so it's between two blocks. It's cool. All right. And then when we try to find halfway between those, it's going to be a little bit weird. Okay, but we can still handle this. So that's going to be about here, right? Ish will be halfway between. Okay, so then halfway between these guys is going to be about there-ish. Okay, and we can use that then to extrapolate our pattern. So it's sort of like every, like, let's see, if this was halfway between, so it's like every 1.25, you should be at the next thing. So it's a little bit weird, but you can kind of use this to follow a pattern. Like I would probably do this. I'd go through and just put points on my midline and then go through and just add the up and down points. So halfway between those is about there, halfway between those is about there, halfway between those is about there, halfway between those is about here. Okay, I'm not asking for perfection here. You're just giving it your best estimate. Okay, and then once we have that, we can squiggle our graph on. Okay, this one's a little bit weird because it's not exactly on boxes, but it's not the end of the world. It's a little bit weird. All right, so then our last one here. So this one, this number in front, that's my amplitude. So my amplitude's 4. So I'm going 4 above and 4 below my midline. So here's 4 above my midline. Here's 4 below my midline. All right, and then for my period, right, I'm looking for this number that's in front of theta. There's an invisible 1 there, right? So my period is just going to be 360 divided by 1, or 360. Okay, cosine graph. So cosine, like a roller coaster, you got to start at the top of the hill, right? And then 360 is where you're also at the top. That's my period. Halfway between 0 and 360, that's at 180. That's where I'm at the bottom. Okay, and again, that's a really common mistake that people make. Okay, because a lot of people, because sine would be halfway between these 2 points in the same spot, a lot of people do that. So you just got to kind of train your brain. It's halfway between, but at the bottom for cosine. Okay, and then halfway between those is where your crossover points are. Okay, and then that gives me enough information to build a pattern. Every 2 vertical lines, I move to my next position. So after 2 vertical lines, I'll be here, and after 2 more, I'll be there. And there's my graph. Okay, try to make those look nice and curvy. You don't want V's, okay? They shouldn't be pointy. You want to make them kind of curvy. All right? Okay, so that is how you graph a trigonometric function when you're not dealing with any shifts. So no vertical shifts, no horizontal shifts. Okay, next time that we do something new, we'll be adding in the vertical shifts. Okay, we'll practice these a little bit, add in our vertical shifts. Okay, but we're not going to be doing horizontal shifts in this class. So just vertical shifts, so it shouldn't be too bad.